Have you ever stopped to think about sperm and egg cells as, well, as these incredible little machines? Because that's really what they are. Each one is a highly specialized piece of biological engineering designed for one single, absolutely crucial mission: to create the next generation. So let's dive in and take a look at how this amazing design process works.
Okay, so it all starts with a huge biological puzzle. Every living thing, including us, has a complete genetic instruction manual inside its cells. So, how do you combine two of those manuals, one from each parent, without ending up with, a book that's twice as thick and totally unreadable?
Well, the solution is just beautiful in its simplicity. Instead of trying to mash two whole blueprints together, life gets clever. It creates these specialized messenger cells, the sperm and the egg, and each one carries exactly half of the genetic code. So when they finally meet up, boom, the blueprint is whole again. Perfect.
So what is the ultimate mission for these cells? It's all about something called genetic continuity. It's this incredibly important job of passing on the perfect amount of information from one generation to the next without any mistakes. Now, the proper scientific name for these little messengers is gamete, and their number one defining feature is that they're haploid. I know it's a bit of a sciencey word, but all it means is they have half the number of chromosomes that a normal body cell has. That's it. That's the secret sauce.
Let's put some real numbers on this to make it clear. Your typical human body cell, in your skin, your heart, your brain, it has 46 chromosomes. You can think of these 46 chromosomes as the full, complete, unabridged instruction manual for building you. But then, through this absolutely remarkable process called meiosis, the body makes gametes that have just 23 single chromosomes. And this right here, this is the most important step in the whole process. By cutting that number in half, it guarantees that when a sperm and egg combine, the new cell gets back to that perfect total of 46. Not 45, not 47, exactly 46.
Okay, now let's meet our first specialist. I want you to think of the sperm cell as a high-tech biological torpedo. It's been stripped down to its bare essentials, totally optimized for one thing and one thing only: delivering its precious genetic cargo.
I mean, just look at this design. It's incredible. Every single part is built for the mission. There's nothing extra, no fluff, no baggage. It's all about movement and delivery. You're looking at the absolute pinnacle of minimalist biological design. So, let's break down the hardware. First, you've got the flagellum. That's the powerful motor, the propeller that drives it forward. Then, there's the midpiece. This section is just crammed with mitochondria. They're like tiny little battery packs, providing all the energy for that long, tough journey. And right at the very tip, you have the acrosome. Think of that as a specialized tool, a cap full of enzymes designed to breach the egg's defenses.
And now let's meet our other specialist. And it could not be more different from the sperm. The egg cell isn't designed for travel at all. No, it's basically a self-contained life support system, fully prepped and waiting to receive that genetic package and kickstart a new life.
I mean, the difference in strategy is just staring you in the face. The egg is enormous, absolutely gigantic compared to the sperm, and it doesn't move on its own. Its entire being is geared towards one thing: protecting and providing all the resources needed for the first few days of development.
So what exactly are all those sperm trying to get through? Well, the inside of the egg, the cytoplasm, is like a fully stocked pantry packed with all the nutrients needed to fuel a brand new embryo. But to even get to that pantry, a sperm has to get through these tough outer layers, which act like security guards, making sure only one gets inside.
Let's just put them side by side. The contrast is amazing, right? Small versus large. Built for speed versus built for staying put. Millions and millions of them versus just one per cycle. They are perfect complements. One is a tiny, fast-moving messenger, and the other is a huge, stationary, resource-rich nursery.
But here's something that you might not realize. These amazing, highly specialized cells, they don't just pop into existence out of nowhere. They actually need their own dedicated support crew to help them get ready for the big mission.
So on the left, you're looking at Sertoli cells in the testes, and on the right, you've got follicle cells in the ovary. The best way to think about these is like the pit crew in a Formula One race. They're not the ones driving the car, but without them, the car is never, ever going to win. They are absolutely essential. So simply put, the Sertoli cells feed and protect the developing sperm, and the follicle cells do the exact same thing for the developing egg. Now here's the critical point. These support cells are absolutely vital to the process,
but they don't contribute any of their own DNA to the offspring. They're just the support team. So you might be asking, what's the point of all this extreme specialization? Why all the different designs? Well, the answer is actually pretty simple. In a single word, success. This entire system is fine-tuned to maximize the chances of successfully creating a new life.
And here you can see that perfect partnership in action. The sperm's incredible speed and sheer numbers dramatically increase the odds that at least one will reach the egg. And at the same time, the egg's massive nutrient supply and its protective layers ensure that if and when fertilization happens, the embryo has the best possible start in life.
And this, right here, is the ultimate takeaway. These very specific, very specialized structures lead directly to reproductive efficiency. And that efficiency is what ensures the survival of the species. Every single feature we've talked about today is the result of evolution, honing this process to near perfection over millions of years.
It really is just an incredible marvel of natural design when you think about it. And it makes you wonder, right? If this is one highly successful solution for passing on a genetic blueprint, what other completely different, totally bizarre, and absolutely brilliant strategies has evolution come up with across the entire tree of life?